Here we go. So we have graphed linear functions in the last lesson, and we learned that the points lie on the graph, and they're simply XY ordered pairs. So we already know this. So we're just going to jump right here to this inequality. Y is greater than X plus 3. I need you to tell me if any of these ordered pairs below are solutions. How am I going to do that? Huh? Can't I just plug them in for X and Y right here into this equation? I can. Okay. So remember that the first coordinate is the X and the second one is the Y. So instead of using Y, I'm replacing the Y with a 7 is greater than 2 plus 3. Is that true? Is 7 greater than 5? Yes. So this is a solution, meaning it would be in the shaded region. Okay. Let's try the number 0, 1. So remember, those are my X and my Ys. So what am I replacing Y with? 1. 1 is greater than X plus 3, which is 0 plus 3. That says 1 is greater than 3. Is that true? No, not true. Not true, so it's not a solution. Okay? Are we good with that? Okay, let's try it again. This is my X and my Y. So I'm replacing the Y with what letter? Or sorry, what number? 4 is greater than X is 1 plus 3. Is 4 greater than 4? No, it's not. 4 is equal to 4. 4 is not greater than 4. So the only point that would be in the shaded region would be the first one. So I'm going to write some notes about that. So this point would be in the shaded region. This point right here would be on the dashed line. If it were a solid line, 4 is greater than or equal to 4, it would work. But since it's not a solid line, it's not the greater than or equal to symbol, that tells me that that point would be right on the dashed line. And it's going to be a dashed line because we're using greater than instead of greater than or equal to. So now it says graph the line y equals x plus 3 on the grid below in dashed form, because we really know that it's this inequality. So where do I begin? Where do I begin? What is my b? 3. What is my slope? 1. So that's 1 over 1. So I'm going to begin at positive 3, and I'm going to go up 1 over 1, up 1 over 1. And I'm going to connect these with a dashed line. Okay. The ordered pair that we tested first, the ordered pair that we plugged in first was the ordered pair 2, 7. So 1, 2, up 1, 2, 3, 4, 5, 6, 7. I know that 2, 7, that ordered pair is a what? Did we say that 2, 7 was a solution? And so that means it's going to be in the shaded region. So I'm going to shade that. I'm going to shade this side, which makes sense because I'm shading above the line. I'm shading above the line. The ordered pair 0, 1, which we tested, would be right here. Is that in the solution set? No, it is not. The ordered pair 1, 4 that we tested is right here. And it's on the dashed line, which means it's not part of the solution because it's a dashed line. So this is on the dashed line. It doesn't count. So we graphed it, and part C says plot the points that you did to show that you have the correct solution. We did that. Part D says choose one more point. Choose one more point that is in the shaded region and prove that it's a solution. So someone pick an ordered pair from the shaded region. Tell me what it is. Eli. 1, 6. 1, 1, 2, 3, 4, 5, 6. Eli's picking the ordered pair 1, 6. I need to change the color really fast. Ooh, ding, ding, dong. I don't think you can see that any better, but there we go. We're picking the point 1, 6. And we have to check to see it. We have to prove it. How are we going to prove it? Well, we're going to plug it into this inequality. Y is greater than x plus 3. Y is what number in our ordered pair? 6. 6 is greater than x is what number from our ordered pair? 6 is greater than 1 plus 3. And that means that 6 is greater than 4. Is that true? Yeah, that's why it's in our shaded area. Good? Okay. The point 10, 12 cannot be drawn on the grid above, so it's difficult to tell if it falls in the shaded region. Is 10, 12 part of this solution? Tell me how you would determine that. So we can't graph the point 10, 12 to see if it's in the shaded region. What do you want to do with it, Gavin? Yeah, plug it into y is greater than x plus 3. So what value am I substituting in for y? Naya. Looking at the ordered pair, what's the y value? Awesome. 12 is greater than, what value am I substituting in for x, Antoine? 12 is greater than 10 plus 3. That means 12 is greater than 13. Is that true? So is 10, 12 in the shaded region? Not a solution. It is not in the shaded region. It's just not in the shaded region. That's all that means. Okay, you guys know how to plug in and check an ordered pair. You've been doing that since we started solving equations. Check your answer, right? Okay. There are some challenges to graphing linear inequalities, especially if the output has not been solved for, meaning you have to solve for y. So this is just what we did yesterday. So we're going to look at this inequality, 3x minus 2y, so a little bit more practice from yesterday, and we have to solve it. So 3x minus 2y is greater than or equal to 2. I need to make it look like y is all by itself. I want it to be y is blah, blah, blah. What should I do first? Eli. How about subtracting 3x? Yeah, subtract 3x. So I have negative 2y is greater than or equal to negative 3x plus 2. Okay. I am dividing by a negative. What's the special rule when you divide by a negative? You're right. Say it. Don't listen to them naysayers. Flip your inequality. You got to flip that. So I'm going to flip it right here. So I remember to do that. Flip, flip, flip. So y is now less than or equal to, that negative divided by a negative becomes a positive 3/2 x, and a positive 2 divided by a negative 2 becomes negative 1. So where am I going to begin? Begin at negative 1. What is my slope? 3/2. Okay, so let's graph that. Are we going to have a solid line or a dashed line? Solid. So begin at negative 1. I'm going to go up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. And I'm going to connect those with a fabulous solid line. Okay. Say that again. This is the last page of notes. I said we were doing one full page, front and back. So yeah, you're interrupting. You're just making me repeat the same things I already said. This is it. We're almost done. I promise. So it says pick a point to determine the shaded region. Well, we know from the inequality that we should shade which direction, because the symbol that we're using is this. That means we're going to shade down below. Okay, so that means we're going to shade below the line. But let's pick the point 0, 0, which is not on the line or in the shaded region. And let's check it. If we check the point 0, 0, should it work? No, we should get something that's not true. When we check that, we should come up with a statement that is not true because it is not in the shaded region. So let's check. If y is 0 less than or equal to 3/2 times 0 minus 1? This says 0 is less than or equal to -1. Is 0 less than -1? No, it is not. That is not true. That's why the point 0, 0 is not in the shaded region. Okay. All right. We have a horizontal line and a vertical line. Vux. Which one is horizontal? Which one is vertical? Hoi. Remember yesterday, Vux, hoi. X is vertical. Y is horizontal. Good job. Okay. So vertical line, I'm going to go to where X equals 4 on the X axis, and I'm going to make a vertical line. Is it going to be solid or dashed? Dashed. Dash, dash, dash. I'm trying to make it really thick so you can see it. So I have a dashed line. And this says all numbers less than 4. So which way am I going to shade? To the left, to the left, to the left. Okay. Yeah, sorry. Shade to the left. Because. So the y is greater than or equal to -2. Solid line or a dashed line? Dakota, what do you think? Solid or dashed? Solid. Horizontal line at -2 on the y-axis. This says all numbers greater than or equal to -2. So I'm going to shade above it or below it. Above it or below it. Above it. What are your thoughts? Easy? You like it? You're just plugging it in. I'll start you off on it. That's all right. So here's your homework, pages 8 and 9, and you have an interactive practice. So homework is pages, yes, you can go to the restroom. Pages 8 and 9. I'll start you off on the first one. Give me a second. Can you? Okay. Yeah. Is she copying notes? Here. Yep, I got it. I'll pull it back. There you go, ma'am. Sorry about that. Done? Okay, Dakota, I'll leave this first one up for you when you come back. All right. So we're just taking this inequality. Y is greater than or, oh, that's horrible. Start again. Y is greater than or equal to 2x minus 4, and I'm plugging in the ordered pair. So what value am I replacing y with? Kate? Greater than or equal to? Yeah, it is. So what is 2 with a 5 in parentheses equal to? Yeah, that's 2 times 5 is 10. What is 10 minus 4? So is 4 greater than or equal to 6? No, that's not true. It is not a solution. You are doing it right. You got it.